Ahoy hoy, I'm Planarwalk, and there's been this thing that's been going around in the flerf communities called relative density. And it's basically an idea that all you need to make things rise or fall is density. Now, like most pseudoscientific claims, it's very difficult to debunk because it offers no calculations, it has no explanation of how things are happening. All it says is that if I have an object and I drop it, and it's denser than the medium around it, it will fall, and if it's less dense than the medium around it, then it will rise, and if it's the same density as the medium around it, it will just stay where it is. But fortunately, we do know enough about it that I can actually go ahead and design an experiment that will debunk it. So what is it that we know about relative density? Well, we know that it's a force, and we know that it's supposed to replace buoyancy. Now, the replacing buoyancy part is very important, as this suggests that it's an interaction between two different things rather than an external force like gravity or magnetism. I mean, it still doesn't explain where we get a vector from, but I'll drop that for now. So seeing as it's a difference in density between two different substances, if I were to take this bottle of water here, poke two holes in the bottom of equal sizes, and watch the water come out of those two holes, and measure the amount of water that comes out of each hole, it should come out of each hole at the exact same rate. And the reason for this would be the air around the water doesn't have any major variation in density, and the water doesn't have any variation in density because it's an incompressible fluid. So therefore, any force that results from an interaction between the two would be the exact same. So here's where the little experiment comes in, and where the idea of relative density will conflict with reality. Instead of putting two holes on the bottom, how about I put two holes on the side at different heights? Because the difference in density would be the exact same, water should just flow out of both holes at the same rate, right? It's big brain time. So, there's two holes in this bottle, one right there and one right there. It's very hard to see due to the way that my camera focuses. It doesn't like focusing. So, let's flip this bottle upright and see how fast the water comes out of each hole. They're roughly the same size, so let's see what happens. And we have water flowing out of both holes. We've got water flowing out of the one on top, and oh dear. Oh dear. Huh. Water's coming faster out of the bottom hole than the top hole. Huh. That's bad. I thought relative density might have been a thing, but maybe not. Well, if only there was an explanation for why this is happening. Now, I've even gotten the lid undone, so that's not the reason. I know. There was an explanation I was reading about. It's called, starts with G. Isn't gravity, maybe? Yeah, that could be a thing. It's barely even moving out of the top hole now. Yeah, gravity might be the reason why one is coming out faster than the other. Although, obviously, gravity wouldn't be the sole reason. It's got to do with how all the force... Oh, there's actually quite a few reasons. It's basically stopped coming out of the one on top. Not enough pressure to push it out, so it's just coming out of the one on bottom. The one on bottom is actually slowed down a bit as well. Not as much pressure. So that was a bit of a flunk for relative density. So there's something that I'm guessing flat earthers might say in response to this. They might go something like, well, you don't have any explanations for why it's doing that, and actually I do. So here's what's happening in very simple terms. Gravity is acting on every bit of water in that container. And also what's happening is because gravity is acting on every bit of water that's above another part of water is pushing down on that water. So if you were to divide the water up into 5% segments, the top 5% of water would be pressing on the next 5%, which would be pressing on the next 5%, which would be pressing on the next 5%. So the top part of the water only has gravity acting on it. But as you go further down in the water, not only do you have gravity acting on it, but you've got all the water above it pushing down because gravity is acting on that, and every bit of water above that is also pushing down on it, which creates an effect of, as you go further down, you've got a lot more pressure pushing down on it than further up. So therefore, because of that, the water comes out of the bottom hole much faster than it comes out of the top hole. Very simple stuff. And there's probably much better explanations of it than the one that I've given, but I'm trying to explain it in a very simple way here so that even flat earthers can understand it. There's also heaps of other experiments that you can do that can debunk relative density, but that was the easiest. Just wait until flat earthers come up with other bullshit like relative pressure. There's an easy way to debunk that too. Flat earthers, if you feel like that experiment doesn't actually debunk relative density, please explain why, and it would be nice if you could give a few numbers and stuff so that I can actually do a few tests with the experiment, see if the numbers add up and all that kind of stuff. Anyway, leave a like and subscribe if you like that video. Leave a comment giving me other video ideas, although I really don't think I need more video ideas at this point. I'm really backed up with video ideas. As always, a big shout out to my $20 or more patrons. Fight the Flat Earth, Stantrucker, What Jesus, Robert Legere III, and Wolfie. If you want to support me financially, you can do so on Patreon, link will be in the description. But anyway, I will see you in the next video. Between you and me, thank you for watching. Ha! Oh god, it's following me and it won't go away, go away, go away. Oh god, no, don't. How do I lose this thing? It won't stop following me. This is what I have to put up with when programming.